This is my geometry course. Today we're going to learn the distance formula and how to find the midpoint in two dimensions. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. We're going to start by learning the distance formula. Here's the formula. I know it looks a little scary, but you're going to find that it's not too bad. The distance formula helps us to find, obviously, the distance between 2 points. You see these two red dots here, those are our points. And we're going to find the distance between them, which is this green dotted line. Now this is point 1, and this is point 2. That's why we've labeled the x and y value x1 and y1 for point 1 and x2, y2 for point 2. This is the way it's traditionally done. And you plug these values into this formula, and you can find the distance. Now I want you to understand very clearly that this formula is actually from the Pythagorean theorem. That's the theorem we used for right triangles in a previous class in this course. A squared plus b squared is equal to c squared. But what we do is we find c, we square root both sides, and we find c, and that's really where the formula comes from. C is the same thing as d in that formula. So we're really making a right triangle, and you can see if we drop a vertical and draw a horizontal from those 2 points, that's why we're using the Pythagorean theorem. We're using a right triangle. And this distance here is the difference of the y values. Subtract the y values, and that's this length here. And subtract the x values, and that's the length here. And that's where these come from. Instead of a squared plus b squared, it's x2 minus x1 squared and y2 minus y1 squared. So again, I know that seems kind of complicated, but don't worry. Most students really are completely unaware that this comes from the Pythagorean theorem. They don't even think about it. And you don't have to think about it either if you don't want to. You just have to know how to plug in numbers to that formula. I'm just giving you a quick explanation of where the formula comes from. So again, if you replace those values with a and b, and the distance with c, you see we have the Pythagorean theorem. So I want you to be aware that there's actually 2 ways to find the distance formula, or to find the distance between 2 points. You can just plug numbers in, or you can draw a graph and make a right triangle and find these lengths and just use the Pythagorean theorem directly. So we're going to use both methods. So again, if you don't understand all that, that's okay. We're going to do some practice problems, and you're only required to be able to find the distance. You don't really have to understand where those formulas or where that formula comes from. So we're going to find the distance between the following 2 points. We have 2 coordinates here, or 2 points, and we're going to use two methods. We're going to start with the formula method. And we're also going to do what I call the graphical method. That's where you draw a right triangle on the graph and then just use the Pythagorean theorem directly. Now I want you to get a screenshot of this formula here, because we're going to use that many, many times. And so what I'm going to do first is I'm going to assign letters to each number. So we have x1, y1, and we have x2, y2. So I'm making this point x1, point 1, and I'm making this point 2. And this allows us to figure out which number goes where in the formula. And I want you to understand that we could make this point 2 and this point 1. It really doesn't matter. It doesn't matter which point is 1 or 2, but if you write x1 and then y2, that doesn't make any sense because you have a 1 and a 2 in the same point. The numbers have to be the same for each point, so you have to have both 1s or both 2s. All right, so now we're going to write the distance formula. We're going to show the tool that we're using. So that's that distance formula that we saw over there. And now all we're going to do is just plug in numbers. So x2 is 7, x1 is 1, and y2 is 11, and y1 is 3. And now all we have to do is just calculate this expression. We just have to simplify it, and we'll be done. Now, there's a couple things I need to explain. In order to simplify this, we need to follow the order of operations. And the problem with following order of operations, remember we learned that in arithmetic. It's PEMDAS. This tells us to do parentheses first, then exponents, then division. Or excuse me, then multiplication, then division, then addition, then subtraction. But the problem is we have a square root here. This doesn't say anything about square roots. So this is a part of the math curriculum that is kind of lacking. It doesn't really tell us, that the order of operations doesn't tell us what to do here. But there is a way to kind of make this root an expression with a parenthesis, but that takes advanced mathematics we haven't learned yet. That actually uses something called a fraction power, and we're not going to go into that. So just be aware that you need to do the inside part first before you square root. Square rooting is going to be the last step in this particular type of expression. Now, a lot of students will say, wait a second, we have a square root and we also have squares inside. So doesn't that square root just get rid of the squares? We learned that in my beginning algebra course. So a lot of students would say we can just simplify it to this. Well, we can't do that, because it, like I said, it violates order of operations. We have to do the inside part first, then square root. That's probably the biggest mistake that students make, or one of the biggest mistakes. We're actually going to talk about two of the biggest mistakes students make in the math curriculum in this class. And this is the first one. A lot of students say that the square root of a squared plus b squared is equal to a plus b. That is not correct. Now, if you're multiplying a squared and b squared, if you've got a squared times b squared and you're square rooting, then that equals a times b. This is true. This is not true. So just be aware of that. So I know that's kind of a boring thing to go into, but I just wanted to explain that real quickly. So what we're going to do is we're going to do the parentheses first. So 7 minus 1 is 6, and 11 minus 3 is 8. And PEMDAS tells us then to do exponents. So 6 squared is 36, 8 squared is 64. Then we're going to add and we get 100. And this is asking us what number, and by the way, if you forgot what second power means, 6 to the second power just means 6 times 6, which is 36. If it's been a while since you saw that. And that just means 8 times 8, which is 64. You're just taking the number, multiplying it by itself. Now, what does the square root symbol mean? What does that mean? Well, it means it's asking what number times itself equals 100. So think about that. What number times itself is equal to 100? We learned this in my beginning algebra course. Well, 10 times 10 is 100, so the answer is 10. So there you go. So that is the answer. That is the distance between these 2 points. But as I said, there's a graphical method also that I'm going to show you. And after you see these 2 methods, I want you to decide which method you prefer. I don't want you to use both methods because it's going to take too long. This type of problem that we just did should take you no more than about 30 seconds once you get used to it. Okay, so I don't want you to think that these problems take a long time. But I'm going to show you both methods, so it's going to seem like this is going to take a lot longer than it really does. I want you to watch both methods, and then after this problem, I want you to decide which method you prefer, and you can use that method, but don't use both of them, because again, it's going to take too long for you to do each of these problems. It should only take you about 30 seconds. All right, so I'm going to make the biggest mark there 12. And try to make your divisions roughly equal in length. That's not really equal, but your graph doesn't have to be perfect. So we have 12 and 12. And I'm going to mark these points. So I have 1, 3 up here. So 1, 3 is going to be about here. and I have 711, which is going to be about here. And I'm going to mark those points. We got 711, 711. That's that point, and then over here we have 1, 3. So this graphical method, again, what we're going to do is we're going to draw a horizontal, and we're going to draw a vertical, and we're going to draw it right under. Whoops, sorry about that. And by the definition, these are called rectangular coordinates. By the definition of rectangular coordinates, because we have vertical units and horizontal units, just by the definition of vertical and horizontal units, these line segments are perpendicular, which means that this angle between them must be 90 degrees. It must be a 90-degree angle. That's where the distance formula comes from. So now we connect the dots, and we see we have a right triangle because, again, this angle is 90 degrees. So what we can do is we can use these coordinates to find the legs of the right triangle. Remember, the distance we're looking for is the hypotenuse. That's the actual length that we're looking for. That's the distance between the 2 points. It's the shortest distance between the 2 points is the hypotenuse of that triangle. We're looking for the hypotenuse. But using these coordinates, these points, we can find these legs of the right triangle. So very quickly, to find the vertical leg, the orange dotted line, we're going to subtract the y values. So 11 minus 3 is 8. That's that length. To find the purple dotted line, the length, we're going to subtract the x values. 1 minus 7 is negative 6. Now, even though it's negative 6, I'm just going to write a positive 6 because it doesn't really matter. When you plug it into the Pythagorean theorem, the negative is going to go away anyway. So just be aware that sometimes you'll get negatives here. If you do get negatives, just turn them to positives. You don't really need them to be negative. It doesn't matter. And it doesn't matter which way you subtract. You can do 3 minus 11 to get negative 8, or you can do 11 minus 3 to get positive 8. It doesn't matter. Just change it to positive. 7 minus 1 gives you positive 6, or 1 minus 7 gives you negative 6. Just change it to a positive. So now we've got the legs of the right triangle, and we're going to use the Pythagorean theorem, which says a squared plus b squared equals c squared. And we're going to plug in 8 for a and 6 for b. Now you could switch them. You could make a 6 and b 8. That's okay. Again, just as long as you don't plug them into the to the hypotenuse, then you're going to get the wrong answer. All right, so go ahead and square those, and we get 64 plus 36 equals c squared. And add them together, you get 100. Now we know c squared is 100, right? We don't care about c squared. We don't want c squared. We want c. So we have to get rid of that second power on the c. So remember, we learned in my beginning algebra course that the opposite of raising to the second power is square rooting. The opposite of squaring is square rooting. So we square root both sides, and we get 10, actually plus or minus 10. Remember, whenever you square root, you have to write plus or minus. But there's no such thing as a negative length. This length cannot be some negative number. So even though in a problem with in an equation with a square on the variable, you usually put a plus or minus when you square root, we can just leave it as positive 10. I guess I'll just leave it like that, and then we'll go c equals positive 10, and then I can change c to d because remember, we're looking for the distance, and we are done. Distance is 10. And you can see that we got the same answer with the formula method. Now again, you might be thinking to yourself, I don't like this. This is taking too long. This is This seems really difficult. Well, again, I'm showing you both methods. You only have to use one method. So it's not going to take this long. And, you know, I'm having to explain it to you, so it's taking a lot longer. So again, choose which method you like. Now, when it comes to the graphical method, let me show you the positive and negatives real quick, the positives and negatives of both these methods. The most difficult part of the graphing method is finding these lengths. Students have a lot of trouble with that. Just remember that if you subtract the x values, you get this distance here. If you subtract the y values, you get this distance. Now, some students might ask, well, why is that? Well, it just depends on how well you understand coordinates. If you understand how coordinates are designed, rectangular coordinates, then you should be able to see fairly easily why that is true. I never really did when I was learning this stuff. I just memorized to subtract it. I don't want to go in and do a lengthy explanation of why that is. You can figure it out yourself if you really want to know, but all you have to do is just subtract those x values for the horizontal leg of the right triangle and subtract the y values for the vertical leg of the right triangle. But we should move on. I don't want to bore you with too much information here. So again, choose which method you like. Again, this is the hardest part of the graphing method, is finding these lengths. And the hardest part of the formula method is that students sometimes have trouble with signs. We're going to do problems where you have to have double negatives. So sometimes students don't plug in the numbers or they don't plug them in and do the operations correctly. But again, I want you to be aware I'm going to be doing both methods. So this video is going to last probably for at least 2 hours, simply because I'm doing both methods. You don't have to watch both methods, just watch one method. So if you like the formula method, follow me on this problem. But if you prefer the graphing method, fast forward to when I demonstrate the graphing method. So the formula method, we're just going to do another problem here, and we're first going to label the letters, or label the numbers with letters. And now we're going to use the distance formula. We need to show the formula that we're using. I want to make sure that I wrote that in the correct form. There's a lot of different ways to write it. So now we just plug in numbers. So x2 is going to be -5, and x1 is going to be -1. Now here's the part where students start to have some trouble. This is a double negative. So the notation starts to get a little confusing. Notice all those parentheses. Then we have y2, which is -7, minus y1, which is -2. Look at all these parentheses I have to write. You're probably thinking, I don't have to write all those parentheses. Yes, you do. This is how you notate the math. You don't have a choice. You can't make up your own language and expect everybody else in the math world and the science world to just go by your language. This is how you have to do it. A lot of teachers think, well, I can make it easier for students and I can change the language. No, you can't. You know, teachers are, it's like if I'm an English teacher and I say, you know what, I don't like how that word is spelled, I'm just going to change it. You can't do that. You have to use the language that everybody else in the world is using, or else you're not going to be able to communicate. Let me change the size of that a little bit. All right. So again, here's the part where students have a lot of trouble. You got to really make sure that you're doing these operations correctly. -5 minus -1, that's a double negative. So when you subtract a negative, it becomes, those two negative signs become positive. Now be aware that this negative has nothing to do with what we're talking about. Okay, it's these two negatives that become positive. So those become positive, and you know, you should be aware of these things by now, but just in case you forgot, I'm just reminding you. We went over these things in my pre-algebra course. So we have another double negative that becomes +2. So now we got rid of those double negatives. Things are a lot easier now. And we have -5 plus 1 is -4. Now, here we are at another critical point. A lot of students will write -4 squared, and then -7 plus 2 is -5. They'll write these expressions here. These are wrong. Okay? -4 squared, the correct expressions require parentheses. These are the correct expressions. All right? Now I know what you're thinking. You're thinking this is so dumb. What does it matter if we put little parentheses there? Why does it, who cares? Well, the whole point of this course, and just about every other math course, is to learn the language of mathematics, and it's improper language to leave those parentheses out. It's like if you spell the word the T-H-A instead of T-H-E or something like that. You're not using the language properly. So you can't just use whatever language you want to. Negative 4 squared without parentheses is not equal to negative 4 squared with parentheses. Why is that? Because this is negative 16 and this is positive 16. It means something completely different. So no, you cannot just make up your own language. This is not allowed here in this context. We talked about one of the most common mistakes that students make. The square root of a sum of squares is equal to the sum of the base numbers there. That's not correct. That's one of the most common mistakes that students make. This is probably the second most common mistake that students make, is saying negative 4 squared without parentheses. So anyway, I think you got the point. So negative 4 squared is 16, and negative 5 squared is 25. So now we just add those up, and we get, I think we get 41. And you really can't do anything with that, so we just leave it as square root 41. So that is the formula method. So if you prefer that method, you can just skip to the next problem, problem number 3. But I'm going to now demonstrate the graphical method. If you prefer the graphical method, then you skipped past the formula method. Again, this video is going to go for 2 hours if you don't skip forward. You don't want it to be that long. It should only be about an hour and a half. You're probably thinking, I don't even want it to be an hour and a half. Well, I understand that, but you need to do these problems so you can understand the homework. All right, so we're going to start by making our divisions here. We have negative 7 as the biggest number, so it looks like we make 8. That's a good number to make the biggest number there. And again, your graph doesn't have to be perfect. You can see my graph is really not perfect, but that's not really the point. Negative 5, negative 7, that would be about down here. And negative 1, negative 2, that would be about here. And I'm going to label those points. And by the way, you don't have to do all this labeling if you don't want to. This is just for your sake, so you can see. You don't have to label the points if you don't want to. Let's see here. So I'm going to make a vertical and a horizontal, and we're looking for the hypotenuse. So the big thing here is to find those lengths that I was telling you about. This length here is going to be the difference of the y values, negative 2 minus negative 7. That's a double negative. So that would be positive 5. That's that distance. And now we're going to subtract the x values, negative 1 minus negative 5. Again, it doesn't matter the order that you subtract in, and that's going to be positive 4. So now you just use the Pythagorean theorem, because we've got a right triangle with, and we have the legs, so a squared plus b squared equals c squared. Again, we learned this Pythagorean theorem in a previous class. And we have 5 squared plus 4 squared is equal to c squared. Doesn't matter which one is which. 25 plus 16 is equal to c squared. 25 plus 16 is 41. And we've solved for c squared. We now know what c squared is, but we don't care about c squared. Okay, we want c. So we have to square root both sides. And again, I'm not going to put a plus or minus, because we know lengths cannot be negative numbers. So we just change that to d, and we have root 41. And you can see that's the same answer that we got in the formula method. All right, so we're going to do a couple more of these together so you can get the idea. If you prefer the formula method, go ahead and watch me do the formula method. If you prefer the graphing method, go ahead and skip forward to the graphing method. In the formula method, we're going to assign letters, and then we're going to write our distance formula, and then we're going to plug in numbers. So x2 is -1, x1 is 5, y2 is 3, and y1 is 1. Now we just do the operations. -1 minus 5 is -6, and remember to put those parentheses. 3 minus 1 is 2, and we don't need parentheses on that one because it's a positive 2. -6 squared is 36. 2 squared is 4. Again, that's -6 times -6. That's what -6 squared means. That's positive 36 because a negative times a negative is a positive. And we have square root 40. Now, this is something a little different here. You need to pay attention to this. This is something that students typically really do not like, but you have to do it. There's a perfect square inside here. There's a perfect square factor. You're not allowed to leave perfect square factors inside roots. So we learned how to do this in my beginning algebra course. 40 is it's 2 times 20, and it's 10 times 4. It's 4 times it's 5 times what would that be? 5 times 8. That's another way to do it. You can factor this in many different ways, but I'm going to factor it as 4 times 10 because I know 4 is a perfect square. So 4. Well, let me just explain how this works. So if I factor something to a times b, that equals root a times root b. Okay, we learned that in my beginning algebra course. So I'm gonna show the factoring here. I'm not gonna do it every time because again, this is just review. But we're gonna factor this to 4 times 10, and then we're gonna change it to root 4 times root 10 using this principle. Again, you may think, well, I don't like that, and I've never seen it. Well, yes, you have seen it. If you took my beginning algebra course, which is a prerequisite for this course, you saw this at least one time. If you're a little rusty and you forgot, that's completely fine. But if you say that you've never seen this, that's not okay. That means that you didn't take my beginning algebra course, or you took it, but you actually didn't do the homework. So just be aware that we need this principle here. So now the square root of 4, that's just 2. 4 is a perfect square, and I can rewrite the 10. We can't do anything with square root 10. So again, this is asking what number times itself is equal to 4. Well, obviously that's 2. Now I can just get rid of that dot and put the 2 right in front of the root, which is another thing that students really don't like. They don't like seeing that 2 right next to the root, but that just means 2 times root 10. And that is the answer. So I'm going to, I'm going to move that over a little bit. I can move it over later if I need to. So that is pulling out a perfect square. So I'm not going to show every step on that because you can go back and review my beginning algebra course if you want more practice with that. Go to the class on square roots. All right, so now we're going to do the graphing method. And again, if you like the formula method, you can skip the graphing method. If you prefer the graphing method, then that means you've skipped the formula method, and here we go with the graphing method. I'm going to make I want to make 6 the biggest mark there. Again, your graph doesn't have to be perfectly accurate, and we have 5, 1, which is about here, a little bit lower. About there, doesn't have to be perfect, and we have -1, 3, which is about here. Now I'm going to label those 5, 1 and -1, 3. Again, you don't have to label them, it's just for your benefit. I'm going to drop a vertical, and I'm going to draw a horizontal. And then we have the hypotenuse. So we're looking for the hypotenuse, and remember, to find those legs, you just subtract the y values for the vertical. 1 minus 3 is negative 2. Negative 2. But again, you can just change it to positive. We don't really need the negative. You might get a positive 2, you might get a negative 2. Just change it to positive. Subtract the x values. That would be negative 1 minus 5 would give you negative 6, or 5 minus negative 1 would give you positive 6. Again, it doesn't really matter. You know what, I'm going to use a different color on those just so I don't confuse you. So we have 2 and we have 6. So now we use the Pythagorean theorem. A squared plus b squared is equal to c squared. And we have a is 2 and b is 6. And we get 4 plus 36. Add them together and you get 40. And now we know c squared is 40. But we don't want c squared. Okay, we want c. So we have to get rid of that second power, and square rooting is the opposite of squaring. So then we get c is equal to the square root of 40, and we pull out the perfect square, and we get 2 root 10. Now, I explained previously, I should probably explain again, I guess, how to do that. You cannot leave the answer as square root 40. All right, we went over this principle up here. Square root of a times b is equal to square root a times square root b. We learned that in my beginning algebra course. If you forgot it, you can go back to my beginning algebra course and review that. So this becomes, we're going to factor it. Now you can factor it in many ways, 8 times 5, 2 times 20, but we're going to factor it to 4 times 10 because that's just the fastest way to do this. If you do it in other ways, you have to do multiple steps. And using that principle up there I showed you, you break it up into 2 square roots, and square root 4 is 2, and we can't do anything with square root 10. So now I'm going to go up here because we're out of room, and I'm going to get rid of the dot now and just put the 2 next to the square root 10. You can do that when a number is next to a square root, that just means multiplied. And now we can change the c to d, and that is our answer. So you can see we got the same answer as the formula method. Now, why do we factor it in this particular way? Well, because we have a perfect square and we have a number that has no perfect square. That's the way you want to do it. Now, if you factor it to 8 times 5, again, that's just going to make it more difficult because, well, neither of these numbers is a perfect square. If you factor it to 2 times 20, again, neither of these numbers is a perfect square. You want 4 because that's a perfect square in this particular context. All right, so on to the next problem. Problem number 4. If you prefer the formula method, let's go ahead and do the formula method. If you prefer the graphing method, skip to the graphing method. Don't watch this method. There's no reason to watch this method if you prefer the graphing method. All right, so we're going to write our distance formula to show the tool that we're using. And x2 is negative 4, and x1 is 5, and y2 is 1, and y1 is negative 7. So we have a double negative there. Be careful. Negative 4 minus 5 is negative 9. Make sure that you put parentheses around the negative 9. 1 minus negative 7 is 1 plus 7. And negative 9 squared is positive 81 because that's negative 9 times negative 9. A negative times a negative is a positive. And we have 8 squared. And 8 squared is 64. 81 plus 64, that would be 145. Now, we'd like to pull out a perfect square here, because remember, you cannot leave perfect squares inside roots when you're doing the math. Math teachers just want you to simplify, so I don't really know what the factors of 145 are, but that's okay. I can just break out my calculator here. I know it divides by 5, and I get 5 times 29. And both 29 and 5 are prime numbers, so we know we can't really pull out a perfect square, so therefore that is the answer. 145. Root 145 is the distance between those two coordinates. So if you prefer that formula method, go ahead and skip through this, go to the next problem. If you prefer the graphing method, you should have skipped the formula method. And here we go. So I'm going to make the biggest number 8. And we have 5, -7. That would be about here. And we have -4, 1, which would be about here. I'm going to label those points. And then we're going to drop a vertical and draw a horizontal. And the hypotenuse is going to be that dotted green line. And I'm going to subtract the y values to find the vertical, which is the orange. 1 minus -7 would be positive 8. I can do -7 minus 1 would be -8. That's okay, just make it positive. -4 minus 5 is -9. Change it to a positive, you get 9. I could do 5 minus -4, and that would give you positive 9 also. It doesn't matter, just change them to positives. Now we're going to use a squared plus b squared equals c squared, which is the Pythagorean theorem. Plug in 8, plug in 9, 64 plus 81 is 145. So we have found that c squared is 145. We don't care about c squared. We want c. So we have to get rid of that second power. The square root is the opposite of squaring. And we end up with square root of 145 is equal to c. And because we're looking for the distance, we can just change it to d. And we see we get the same answer that we got for the formula method. So you've seen the formula method and the graphical method many times. We've done 4 problems now where you've seen it. You've seen how to do it. So again, you should have an idea of which method you prefer. And now you're going to try some problems on your own. So I want you to try number 5. You're going to find the distance between these two coordinates, and I want you to use either the formula method or the graphical method, but I would not use both because it's just going to take too long to do the problem. I don't want you to get the idea that these problems take a long time. So go ahead and do number 5. Choose which method you want to do, and when you come back, we'll do it together. All right, we're back. If you chose the formula method, well, go ahead and just skip to the answer if you have your answer, and just check to make sure that's correct, and then you can just go on to the next problem. You don't have to watch me do these problems. But if you had trouble with it, if you had some trouble, you need to watch me do the problems and see where you went wrong. And if you use the formula method, I'm going to go ahead and demonstrate that now. So we're going to go ahead and label the numbers and write the tool that we're using. And we're going to plug in those numbers. X2 is 6, X1 is 3, Y2 is 8, Y1 is 4. So we don't have any double negatives here. This is a good starting problem. 6 minus 3 is 3, 8 minus 4 is 4, 3 squared is 9, 4 squared is 16. And add those up, and we get root 25. Now, what number times itself is equal to 25? What number times itself is equal to 25? Well, that's just 5. So the answer is 5. So if you got that answer, good job. So if you prefer the graphical method, let's go ahead and do that now. If you did the graphing method and you got the right answer, you don't have to watch me do this. Let's see, I'm going to make 8 the biggest number. And by the way, when you're drawing these graphs, don't take a long time. Don't get a ruler out and try to make the perfect graph. You don't have time in your life to do that. It's not necessary. The most important thing is that you have the concepts down. So we have 6, 8, which is about here, and we have 3, 4, which is about here. And we're going to mark those 6, 8, and 3, 4. And then we're going to make the horizontal and the vertical and the hypotenuse. And we see we have a right triangle, and we just subtract the x values to find the orange. Whoop, 3, 4. So we subtract the x values and we get -3. So I'm going to change it to +3. Subtract the x values, we get +4. Again, it doesn't matter which way you subtract. You can do 6 minus 3 or 3 minus 6. Just change it to a positive. So now we have a right triangle, and we have the legs of the right triangle, so we can use a squared plus b squared equals c squared. A squared plus b squared equals c squared. Plug in 3 for a and 4 for b. Whoops. And just crunch the numbers, and we get 9 plus 16 is equal to c squared. 9 plus 16 is 25. And we now have c squared. We don't want c squared. We want c. So we have to get rid of the second power. And we have c is equal to 5. And if you want, you can change it to d, because that's really what we're looking for, is the distance. So if you got that answer, good job. All right, so now it's time for you to try another problem. Try number 6. Looks like you're going to have a double negative on this one. So again, if you like the formula method, go ahead and skip forward to see or do the problem. When you come back, we'll demonstrate it. All right, we're back. You should have your answer. Go ahead and check the answer. If you had trouble, you can watch me explain it. If you just want to see the answer, go ahead and fast forward. If you're using the formula method, here we go. If you're using the graphing method, just fast forward to the graphing answer. They're going to be the same answers, so you can check either one. So now we're going to show the formula that we're using, and we just plug in numbers. So x2 is -8, x1 is -6. So you see we have a double negative there. Be very careful. And y2 is 12, and y1 is 9. And so we have -8 plus 6. That might be a source of error there for you. And 12 minus 9 is 3. So we don't really need parentheses for that because it's +3. Now be aware, again, this is a double negative. That's a source of error for many students. This negative has nothing to do with what we're talking about. The double negative is here. These two negatives become a positive. That's just review from pre-algebra in my beginning algebra course. So if you're a little rusty on that, that's okay, but don't act like you've never seen it. -8 plus 2 is 2, or excuse me, -2, and we need parentheses around the -2. Don't just write -2 squared. That's not correct. So now, -2 squared, that's just -2 times -2, which is +4. 3 squared is 9. And we have root 13. That is the answer. So if you got that answer, good job. So you can skip forward to the next problem. If you did the graphical method, go ahead and watch me do the graphing method if you had trouble. Again, you can just look at the answer. If you got the right answer, just go to the next problem. You don't need to see me do this explanation. So 12 is the biggest number. So I'm going to write 12. And we have -8, 12. That would be about here. And we have -6, 9, which would be about here. Again, it doesn't have to be perfectly accurate. So -8, 12. And this is -6, 9. So now we just drop the vertical, and then we do a horizontal. You can see we have a right triangle. It's kind of a small right triangle, but subtract the x values. -8 minus -6 is -2. So I'm just going to change it to +2. And 12 minus 9 is 3. So now we have a right triangle. Legs are 2 and 3, so we're going to use the Pythagorean theorem, which we learned in a previous class. And we have 2 squared plus 3 squared is equal to c squared. 2 and 3 are the legs of that right triangle. So we have 4 plus 9 is equal to c squared. And c squared is equal to 13. So we know c squared is equal to 13. We don't care about c squared. We want c. So we have to get rid of that second power. And we get square root 13 is equal to c, and you can just change it to d because we're ultimately looking for the distance. And so if you got square root 13, good job. All right, time for you to try another problem. And a lot of students will say, I think I've got the idea. Well, that's great that you've got the idea, but I'll decide when you have enough practice. When you watch these videos, you need to do all the problems that I'm telling you to do. Don't skip forward, because each problem has different things, about it, and you need practice. Even if we're doing the same problems over and over and over again, I don't care. You need practice. It helps you memorize the formula. It helps you. It helps you become fluent in the math. So don't skip forward and think, I've got this. I don't need to do this anymore. No. You do need to do it, and I'll tell you how many problems you will do. If you skip forward, then you don't have my guarantee at all when it comes to your knowledge of this mathematics. All right, so now we're going to go on to number 7 and try number 7. And when you come back, we'll do it together. All right, we're back. You can just skip forward and look at the answers if you want. But if you did have trouble, or if you just want to watch me explain how to do it, just to make sure that you you understand what's going on, you can watch me on the formula method. If you use the graphing method, skip forward to the graphing method. So we're going to, as always, write that formula that we're using. And by the way, you don't have to write this distance formula out every single time. I don't want you to get the idea that you have to do that. But I'm definitely going to write it just because I want you to see exactly what we're using. x2 is 1. And x1 is -3, y2 is -3, and y1 is -5. So we have a lot of double negatives here, so you have to be really careful that you do these calculations or these operations properly. Again, the biggest problem that students have with the distance formula is calculating those double negatives. All right, 1 minus -3, that's a double negative, so it becomes 1 plus 3. -3 minus -5, that becomes -3 plus 5. And 1 plus 3 is 4. -3 plus 5 is 2. And we have 16 plus 4, which is 20. So we have square root 20. Now, this is the part where students might have some trouble. There's a perfect square inside here. You can't leave a perfect square. So we're going to factor that to 4 times 5. And then it becomes square root 4 times square root 5. And square root 4 is a perfect square, so that just becomes 2. And we just put the 2 right next to the root, and you're done. So if you got that answer, good job. So you can skip forward to the next problem if you use that formula method. If you're using the graphing method, here we go. You can always, again, you can skip forward to make sure that you got the graphing, using the graphing method, you got the right answer. But if you want to, if you did something wrong, or if you want to make sure you did it correctly, you can watch the graphing method. So 5 is, it looks like that's going to be the biggest, so I'm going to use 6. So 1, -3 would be about here. -3 and -5 would be about here. And we're going to drop a vertical. It doesn't really matter what color I'm using here. I'm not really remembering which purple or orange was vertical or horizontal. And we're looking for the green. So the hardest part is finding these legs, the lengths of these legs. Subtract the x values. 1 minus -3 is 4. And -3 minus -5 is 2. Whoops, I didn't do that correctly. I got those mixed up. Sorry about that. That should be 2 is the vertical and 4 is the horizontal. All right, so that's our right triangle there. We have the leg, so we're going to use the Pythagorean theorem. 4 squared plus 2 squared is equal to c squared. 16 plus 4 is equal to c squared. 16 plus 4 is 20. So now we have c squared. We don't care about c squared. Okay, we want c. So you have to square root both sides. And we have c is equal to square root 20. But you're not allowed to leave a perfect square inside the square root. So we have to factor that to 4 times 5. Sometimes there is no perfect square. For example, if you have something like square root 30, there's no perfect square factor in there. So you can just leave it as square root 30. But now we have square root 20. If we factor it, we can see that one of those factors is a perfect square. It just so happens that all the perfect squares we've had today so far just happen to be 4. But you'll have other perfect squares in these types of problems also. So now we're out of room. So what do we do when we're out of room? We just put a little arrow there. So now the square root of 4, what number times itself is equal to 4? Well, that's just 2. And I can get rid of that dot because when you put a number right next to a root, that means multiplication. And I can change it to the c to d because that's what we're looking for. So if you got that answer, good job. All right, on to number 8. Go ahead and try number 8, and when you come back, we'll do it together. All right, we're back. If you want to just check your answers, you can do that. You don't have to watch my explanations. But if you do want to, if something went wrong, you want to check, then you can go ahead and watch the formula method if you prefer the formula method. If you prefer the graphing method, then skip to the graphing method and watch that method, or just check your answer. All right, plugging in the numbers, x2 minus x1, we have a double negative there. Be very careful about that double negative. y2 minus y1, and 4 minus negative 4 is 8. Actually, I should show the step there. That's 4 plus 4. That's a double negative, so it becomes a positive. And then we have 2 squared. 2 minus 0 is 2. So now, 4 plus 4 is 8. And again, be aware, this is the double negative. That becomes positive. So 8 squared is 64. And so we have the square root of 68. Now, there is a perfect square here. You can use a calculator if you want, but if you divide by 4, you're going to find that 68 is 4 times 17. If you didn't get that, that's okay. But you are going to have to use a calculator or whatever you need to do to figure out if there are perfect squares. And again, it just so happens in this class that all the perfect squares are ending up being 4. So now we just put those numbers right next to each other. That means multiplication. You don't need the dot. And if you got 2 root 17, good job. So now we're going to go on to the graphing method. Again, if you got that answer, you use the formula method, you can just go on to number 9. If you use the graphing method and you did something wrong, you can watch my explanation, or if you just want to check your answer, just go skip forward. Let's see, we're going to make the biggest numbers 4. And we're going to plot those points, 4, 2, and negative 4, 0. Labeling those points. I should probably make these bigger so you can actually see what I'm doing here. So we're going to make a vertical, and you can see the horizontal in this case is actually just going to be on the x-axis. So it's a slightly different problem, different type of problem. So I'm going to make that dotted line on that x-axis, drop the vertical, and connect the dots. So we're looking for that green length there. Now we're going to find the horizontal, the orange dotted line, we're going to subtract the x values. -4 minus -4, or excuse me, -4 minus 4 is -8. You just change it to a positive. I'm going to make it a different color there. And 0 minus 2 is -2, but you can just change it to a positive. So it'll be 2. All right, so a squared plus b squared is equal to c squared. That's the Pythagorean theorem. We just plug in the legs that we found. We get 64 plus 4 is equal to c squared. Add them together. We get 68 is equal to c squared. So we found c squared. We don't care about c squared. We want c. So we have to square root. And so we found c is equal to square root 68. But remember, you're not allowed to leave a perfect square inside there. So if you factor it, you find it's 4 times 17, and 4 is a perfect square, so we get square root 4 times square root 17. And we're out of room. That's okay. You just go up here with an arrow, and square root 4 is 2. You can get rid of that dot and make the c a d, because we're looking for distance. And there you go. 2 square root 17. So if you got that answer, good job. All right, on to number 9. Go ahead and try number 9. Now, number 9 is going to be a little different. You're not really going to see much of a difference when you do the formula method, but when you do the graphing method, something really strange is going to happen. So I want you to, even if you prefer the graphing method, I want you to go ahead and attempt the formula method on this problem, or you can just go along with me as we do it here, because when you see the graphing method, something strange is going to happen. So let's do the formula method together. I'm going to assign letters and plug in, and I'm just going to kind of rush forward here. Let's see here. 4 minus 4. I'm not going to show every single step. 3 minus 6, or actually it would be 6 minus 3. And what's different about this is we get 0 squared and 3 squared. So 0 squared is just 0 times 0, which is 0, and then 3 squared is 9. Maybe I should show that. And then we have square root of 9, which is, what number times itself is equal to 9? Well, that number would be 3. So the distance is 3. So not really a big deal with the formula method, but when you do the graphing method, you're going to see that it doesn't really work like it did in the previous problems. What do we have here? We're going to make 6 the biggest number, and we have 4, 6, which would be about here. 4, 6, and we have 4, 3, which would be about here. So this is very different. Notice that the dots are right on top of each other, you see. So we can't make a right triangle. The triangle kind of collapses on itself. If I take this dot and I move it over, then we can make a right triangle. We can drop the vertical, we can draw the horizontal, we can make a right triangle. But if that dot is right under the other dot, how do we make a right triangle? Well, the answer is we don't. We don't make a right triangle. There is no right triangle. But this makes it really easy, because all we're looking for is this vertical distance. We can easily use these points to find that distance. All we have to do is subtract the y values. 6 minus 3 is 3, and that is our answer. So we can just say the distance is equal to 6 minus 3, which is equal to 3. So that's one way to do it. You could consider an imaginary right triangle where this leg is 0, but again, I don't really think that's necessary. So just be aware that sometimes you get these problems where you don't really need to use the Pythagorean theorem when you do the graphing method. So I want you to try a problem just like that. I want you to try number 10, and you can use whatever method you want to use, and when you come back, we'll do it together. All right, we're back. I'm going to start with the formula method. Again, if you prefer the graphing method, you can just skip forward, or you can just check your answer You don't have to watch me do this at all if you just want to check your answer. So again, I'm not going to show every single step here. 4 minus negative 3 and 5 minus 5. So again, we have a weird situation here. 4 minus negative 3 is 4 plus 3. 5 minus 5 is 0. And 4 minus 3 is 7. 0 squared is 0. That would be 49 plus 0. And we have root 49, which equals 7. So the answer is 7. What number times itself is equal to 49? That's 7. So if you got that answer, you can just skip forward to the next problem. If you want a graphical explanation, you probably should listen to the graphical explanation, to be honest with you, on this particular problem, because it's going to be a little strange. So I'm going to use 6 as the biggest number there. And we have 4, 5. And we have negative 3, 5, which is about there. Now the thing that's different about this is, again, the triangle collapses. Let me go ahead and label those points. 4, 5 and negative 3, 5. Now if I move this, one of these dots, either one, if I move this dot down, again, we can make a right triangle. I can drop a vertical there and draw a horizontal and so on and so forth. But because the dots are right next to each other, because they have the same y value, the triangle collapses on itself. There is no right triangle. So we just have to find this length, but this length is going to be the difference of the x values. So negative 3 minus 4 is negative 7. And of course, you just change it to positive 7. And I'm going to make that yellow so you can see the length there. Just make it positive because there's no such thing as a negative length. So the answer is, distance is just negative 3 minus 4, or you can just change it, you must change it to a positive number. So if you got those answers, good job. All right, so as you can see, the graphing method, it was a little different because now you have a horizontal line as opposed to a vertical line in the other problem. So be aware, if you're using the graphing method, you're going to come up with those situations, but it's really easy because you just subtract the x or y values and then you got your answer. You don't have to use the Pythagorean theorem, so that's good news that you have those problems sometimes because they're easier. All right, so now we're going to do a few more of these problems. I'm only going to do one method for these problems. I'm only going to do the graphing method, so I'm going to get rid of that formula method. I still want you to try these problems. Whether you use the graphing method or the formula method, I want you to try these. These are going to be the last ones. And again, just to save time, I'm just going to use the graphing method. But go ahead and use whatever method you want. And when you come back, we'll do them together. All right, we're back. So I'm going to make the biggest tick mark 6. And I'm going to plot those points 0, 6, or excuse me, 6, 0 and 0, 5. So these are different because the points happen to be on the x-axis and the y-axis. So then I'm going to, maybe I should label those 0, 5, 6, 0, and then drop the horizontal and then drop the vertical and the horizontal. It's kind of hard to see because I'm using that purple color. I guess I can change to yellow. And we have the hypotenuse. So now we can just use the Pythagorean. Well, actually, we still need to find, so we need to find the leg. So 0 minus 6 is negative 6. Change it to positive 6. And 5 minus 0 is 5, so this becomes 5. I guess I should have color-coded those earlier. That probably would have been better. So now we just use the Pythagorean theorem. And again, the only difference with this problem is that the actual legs are on the y and the x-axis. So I just wanted you to see a problem where that occurs. And we have 25 plus 36. looks like we have 61. So we have c squared. We don't want c squared. We want c. So we have to get rid of that second power. And we now have c is equal to root 61. And we can just say d is equal to root 61. The distance between those points is root 61. And you do not have to pull out a perfect square out of 61 because I know that there's no perfect square factor. Now some students might say, well, how do you know that there's not any perfect square factor? Well, it just takes experience, to be honest with you. You can just use a calculator, try to divide it by something, but it's not going to divide by any number evenly. So if you got that answer, good job. And if you use the formula method, you should have gotten the same answer. So again, why are we doing these? We're just doing these because the graphing method looks a little different, as you can see. So I want you to try number 12, and when you come back, we'll do it together. All right, we're back. So the only difference here, let me make the divisions 4. The only difference here is one of the coordinates is actually on the origin. Remember, that's called the origin. And then the other coordinate is, looks like it's about up here. So I have -3, -3, 4. And we have 0, 0. And we're just going to, we're going to connect the dots. We have the horizontal and we have the vertical. And we're looking for this length as usual. So we have the Pythagorean theorem. And subtract the x values and we get -3. I can just change it to +3. And subtract the y values. I can just get +4. And then we use our Pythagorean theorem. And we get 4 squared plus 3 squared. Whoops. 3 squared is equal to c squared. And we have 16 plus 9 is equal to c squared. And we have 25 is equal to c squared. And we have c squared, but we don't really want c squared. We want c, so we have to get rid of that second power by doing the opposite of squaring, which is square rooting, and we get c is equal to 5, and you can change it to d because that's what we're looking for, the distance, and you can see we got the same. Well, we didn't do it the other way, but if you got 5 for the distance, good job. You should have gotten that same answer if you used the formula method. So we are done with the basic distance formula problems. Now, the class, again, if you try to use both methods, this is going to take twice as long. So again, you should have been using one method. If you used one method to find the distances, then you should still have quite a bit of energy in you because we have to do a lot more work here. Because now we're going to learn the midpoint formula. The midpoint, we learned how to find, to find the midpoint on a horizontal segment, it's just the middle point there. It's pretty easy to find. But now we're going to find the midpoint in 2 dimensions. So let's say you have this red dot here. That's point 2, x2, y2, and you have point 1, x1, y1, this other red dot. And you want to find the point that's right in between them. So that means if you were to draw a length, halfway between that length would be the midpoint. That's the definition of midpoint. It kind of bisects the shortest distance between those 2 points. If your points are x1, y1, and x2, y2, then the coordinate of that midpoint would be x1 plus x2 divided by 2. That's the x value of your midpoint. And the y value of your midpoint is y1 plus y2 divided by 2. So this is actually much, much easier than the distance problems. You can take a screenshot of these if you want. Let me get a little closer there if you want a closer screenshot of that formula. Hopefully that's legible there. So you're going to see that this formula is really, really easy. So we're going to find the midpoint between these two coordinates. So I'm going to write an m. Well, first of all, we're gonna need to label the numbers there. So just like we label the numbers with the distance formula, we need to label the numbers with the midpoint formula. And I'm just labeling the point as m for midpoint. You don't have to put that m there, but it's probably best just so you know exactly what you're finding. So now x1 is 3, x2 is 6. So that expression there represents the x value of the midpoint. y1 is -2, and y2 is 1. And now all we have to do is just simplify. 3 plus 6 is 9. -2 plus 1 is -1. And we are done. So as you can see, that's a lot easier than the distance formula. So let's do some more of these problems so you can just get the hang of it. First, we need to label the numbers as usual. y1, y2. And I'm sorry if I'm kind of scribbling here, but if you have that screenshot of that formula, it should be, you should be able to see it pretty easily. So -8 plus 4 over 2, I'm just plugging in the numbers. 6 plus -3 over 2. So just simplify, and we get -8 plus 4 is -4. 6 plus -3 is 3. And -4 over 2 is just -2. And that is the midpoint. Again, very easy. So we'll just do a couple more of these problems, and then you can try a couple on your own, and we'll go on to the next thing. So first, label and the midpoint formula, and just plug in numbers. -2 plus -1, and -7 plus -1 over 2. And all we have to do is just simplify. -2 plus -1 is -3. -7 plus -1 is -8. And we can just simplify 8 over 2. That becomes -4. And there you go. So finding the midpoint is actually pretty easy. On to the next problem. We're going to try one more of these before you try one on your own. So we're going to write the formula out and just plug in numbers. x1 plus x2 over 2, and y1 plus y2 over 2. So then we get 5 over 2, and -6 plus -4 is -10. And simplifying that, we get 5 over 2 and -5, and that's our answer. All right, so time for you to try. Again, if you didn't get a screenshot of that formula, go ahead and do it. And go ahead and try number 17. And when you come back, we'll do it together. All right, we're back. I'm going to assign variables or letters for the numbers, and we'll write the midpoint formula. You don't have to write the midpoint formula every time you do the problem. I just want you to see the tool that we're using. So we plug in x1 is 3, x2 is 1, y1 is 7, y2 is 4, and we have 4 over 2 and 11 over 2. Seems like there's always one fraction in these particular problems. 4 over 2 is 2, and we can just leave that as 11 over 2. You can also write these as decimals if you want. So if you got that answer, good job. All right, try number 18, and when you come back, we'll do it together. All right, we're back. Now we just plug in numbers. -7 plus 5 over 2, that's the x value of the midpoint, and 4 plus -3, that's the y value of the midpoint, divided by 2, that is. You got to divide by 2 or else you'll get the wrong answer. So then we end up with -7 plus 5 is -2. 4 plus -3 is 1. And we have -1 and 1/2. So if you got those answers, good job. -2 over 2 is -1. That's -2 divided by 2. So why don't you try number 19, and when you come back, we'll do it together. All right, we're back. We're going to sign letters so we know what we're doing. And we're going to write out the formula. And we're just going to plug in. x1 is -2. x2 is -5. y1 is -2. y2 is -3. So we have a lot of negatives in this problem. -2 plus -5 is -7. -2 plus -3 is -5. And that is it. So if you got those answers, good job. All right, try number 20, and when you come back, we'll do it together. All right, we're back. Let's go ahead and write the formula out. Again, you don't have to write the formula every time you do this. I'm just showing you the tool that we're using. I don't want you to think that these problems are always going to take a long time. They're really not. So now you just plug in 0 plus 8. 0 plus 8 is 8. 8 over 2 is 4. 4 over 2 is 2. So the point is 4, 2. Have you got those answers? Good job. All right, so we found the distance between 2 points and the midpoint between 2 points. Now we're just going to do some word problems that require you to find the distance when you're given 2 points on a graph. They don't give you the actual coordinates, they just show you the graph. And they give you a word problem. So these are traditional problems, typical problems you're going to see. Find the distance between Lana's house and her favorite restaurant shown on the grid below. The units on the grid below represent miles. So we're going to find the distance between Lana's house and her favorite restaurant. So we're not given the points, we're not given the coordinates. So we have to go ahead and write out the coordinates. We don't have to, but I'm just showing you how to do it in relation to the ways we've already learned. So you can see that this is 1, 2, 3, 4. So it's going to be -4 is the x value, and 1, 2, 3, 4, +4 is the y value. And here we have 1, 2, 3, 4, 5. So that's going to be +5 is the x value, and 1, 2, 3, +3 is going to be the y value of that point. So now it just becomes the same type of problem that we've done in all the other cases. So if you're using the formula method, you just use these points with your distance formula, and if you want to use the graphing method, you can just drop a vertical and then also draw a horizontal, and then you have your Pythagorean theorem, and if you want to find the legs, you just subtract the x values and subtract the y values. So -4 minus 5 would be -9. You can just change it to +9. And 4 minus 3 is 1. You can change it, or just keep it positive there. So that would be 1. So there you have 1 and 9. And just plug it in. But I just want you to be aware, if you're using the graphing method, it's so easy to figure out what those lengths are just because the points are already there. You can just drop a vertical and horizontal, and you can just count the squares in this particular type of problem. So however you want to do it, it's up to you. I'm going to use the formula method also. So distance, and I'm not going to plug everything in. Well, I guess I will for the first problem here, but I'm not going to plug everything in for each of these word problems because going to take too long. I don't think we have time. But as you can see, you just plug in those points, and we have 5 minus -4. It just depends on which coordinate is 0.1 and which coordinate is 0.2. y2 minus y1. And we have, that would be 9 squared and -1 squared. And then we have root 81 plus 1. -1 squared is 1. And we have square root of 82. And I don't think there's any perfect square in there, so that is the answer. But it's not actually the answer, because it says that the units on the grid represent miles. Whoops. The units on the grid represent miles. So we have to say square root 82 miles. And we could just write mi for miles. So remember, when you have a word problem, you're going to lose points if you're taking a test if you don't write the units. Now, if you wanted to use the Pythagorean theorem, you just use a squared plus b squared. And you just plug in these legs. So you get 1 squared plus 9 squared, and so on and so forth. So however you want to do it. I just want you to get a taste for these types of word problems. There's a lot of different types of word problems. Whoops, we have to put miles. A lot of different types of word problems with these midpoint problems and these distance problems. And you can change it to D if you want. So now I want you to try one of those problems yourself. Go ahead and try number 22. It says, find the distance between the pirate and his treasure shown below. The units on the grid represent nautical miles. So I'm not sure what the abbreviation for nautical miles is, but you can just spell out nautical miles in your final answer. So go ahead and try number 22, and when you come back, we'll do it together. All right, we're back. So we're going to write coordinates. So we have 1 over and 1, 2, 3, 4 up. So that's going to be coordinate 1, 4. And this treasure down here is, it's 1, 2, 3, 4, 5 to the left and 1 down. So that's -5, -1. So now that we have the coordinates, it just becomes the same type of problem we've been doing. I'm not going to show every step. I'm not going to write the formula out. I want to get this done quick because you've already seen it tons of times. And we're just going to crunch the numbers, and we get 25 plus 36, which ends up being root 61. Now that's not our answer. We have to write nautical miles. Remember, when you have these word problems, you have to write the units, or else you get points taken off. So you got those answers, or that answer, good job. So these problems are just like the problems we did previously. Now we're going to do a midpoint problem. So let's do this problem together. Sally and Jessica want to meet halfway between their homes to have lunch. The locations are shown below. Find the coordinates of their meeting place. So we want to know the location that they're meeting for lunch. And that's going to be about halfway between, which is about here, somewhere around there. Now, you might say, well, can't I just use the graph and estimate? Well, let's play it on the safe side and use the midpoint formula. So remember, the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. So we just need the coordinates. So Sally's house, it's 1, 2 over to the right and 1, 2, 3 up. So 2, 3. 2, 3, and Jessica is 1, 2, 3, 4. 4 to the right and 1 down. So that's 4, -1. And now we just use the midpoint formula. So it's really no different from the problems we already did. The only difference is they don't give us the coordinates. They just show us the dots, the points on the graph. So now we just plug those in. That would be 2 plus 4 over 2 and 3 plus -1 over 2. And we get 6 over 2 and 2 over 2 because 3 plus -1 is 2. And we have 3 and 1. That's the coordinate of the midpoint. So that would be about 1, 2, 3. That would be about here. That makes sense. Should be about halfway between. So as you can see, it's pretty easy. The only difference is we're just you're given a graph rather than given the actual coordinates in ordered pair form. So why don't you try number 24, and when you come back, we'll do it together. All right, we're back. So let's go ahead and write the coordinates. That's 1 to the left and 1 up. So that would be -1, 1 is that coordinate of city B, and we have 1, 2, 3, 4, 5 to the right, and 1, 2, 3, 4 down. So that's 5, -4. That's the coordinate or the coordinates of city C. And you know what? That's right. Thought I did something wrong there. So now we just use the midpoint formula to find the location of city A. And we're just going to, hopefully you have that midpoint formula out there. I'm not going to write it each time. That would be -1 plus 5 over 2. And 1 plus -4 over 2. And we have 4 over 2, and 1 plus -4 is -3. And we have 2 -3/2, and there you go. So if you got that answer, good job. That's the location of city A. All right, so now we're going to go to a slightly different problem. It's pretty much the same thing as the first distance problems we did with these graphs, but there's a little slight twist at the end. It says, find the distance between 2 anthills shown below in the grid. Each unit on the grid represents 5 feet. So that's the difference, that last little sentence there. Each unit on the grid represents 5 feet. So I'm going to write these points. That would be -1, 1. And this point would be -3, -1. And I'm going to use the distance formula. You can use a triangle, whatever you want to use. So -3 minus -1. And it just depends on which point is point 1 and which point is point 2. So you may do it slightly differently, but that's it doesn't mean it's wrong necessarily. -1 minus 1 squared, and just crunching the numbers there. That's 4 plus 4. So again, I'm doing this kind of quickly because you've already seen all this. So now we get √8. And we're going to pull out a perfect square because 8 is 4 times 2. And by the way, you don't have to show this. I'm just showing it just so you can see what's going on here. So that is the distance, but the distance is in units of 5 feet, you see. It says that each unit represents 5 feet. So if this is our units, each one of those units is 5 feet. So the actual distance, I'll say the distance d subscript a, so actual distance, is equal to 5 times 2√2, because each one of these units, again, is 5. So whatever that number ends up being, you have to multiply it by 5 For example, if this were 7 feet, it's kind of hard to see because it's a root expression, but let's say that this were 7 feet. If each one of those units is 5 feet, or excuse me, not 7, this is 7 units. I said 7 feet, I'm sorry, I'm confusing you, but this is 7 units. We're pretending this is 7 units. If each one of those units is 5 feet, you have to multiply by 5, and it's actually 35 feet. It might be 7 units, but it's actually 35 feet. So this is whatever units this is, we don't know because it's kind of hard to say because it's a root expression, but that's however many units. But each unit represents 5 feet, so we have to multiply by 5. And you may remember from my beginning algebra course, when you multiply these types of expressions, the 5 and the 2 are outside the root, so you just multiply them together, and we get 10 root 2. And we have to say ft for feet. Now, if you are rusty, if you're a little rusty on how to do this, it's okay. But don't say that you've never seen this. This is in my beginning algebra course, so you have seen that before if you completed the prerequisite. So that's the only difference for these problems, is that if you have a scale here, you have to do you have to multiply by that number at the end. So I want you to try a problem like that. Go ahead and attempt number 26, and when you come back, we'll do it together. All right, we're back. Find the distance between 2 gas stations shown on the grid below. Each grid on the below represents 3 kilometers. So I'm going to write the coordinates. Here we have 0, 0, 4, and here we have -1, -3. Using the distance formula, we have -1 minus 0 squared and -3 minus 4 squared and we have 1 plus 49, and that's root 50. Now we have to pull out a perfect square because 50 is 25 times 2. 25 is a perfect square. That's the first time that we've had a perfect square other than 4. And that becomes 5. What number times itself is 25? Well, that's just 5. And so now our actual distance is going to be, it says 3 kilometers for each one of these. So we have to take that number and multiply it by 3. Whoops. Multiply it by 3, and we get 15 root 2 km for kilometers. So if you got that answer, good job. If you didn't remember that kilometers is km, that's okay. All right. On to 27. This is just a short problem here. Kind of a variation of the problems that we've done. George wants to hike to Mount Mobius, but he'll need 2 days to make the trip. If he wants to hike half the distance in the first day, how far will he hike on the first day? So we're looking for the distance between George and Mount Mobius, but we only want half the distance. So this is just kind of a variation problem. So first we're going to write the coordinates. We're going to find the distance between these 2 points, and then we're just going to divide it by 2. So Mount Mobius, those coordinates are 2, 1. You can see just by looking. And George is -3, 1. Or excuse me, -3, 0. So now we just use the distance formula, or you can use your triangle, however you want to do it. And we'll crunch the numbers. Again, I'm not going to show every step. So 25 plus 1. And we get d is equal to root 26. Now the actual distance, because each unit on the grid represents 4 miles, that actual distance would be, well, first of all, we have to divide it by 2. Well, we'll just do 2 steps at once. So actual distance is root 26, but every unit represents 4 miles, so we have to multiply that by 4. So 4 times that. But we also have to take that distance, and the reason this problem is different is because we're not looking for this total distance. We're looking for half that distance. So we then have to divide everything by 2. And if we simplify that, 4 divided by 2 is 2, and we get 2 root 26, and you can just put them together and get 2 root 26 without that dot. Now, a lot of students will say, I've never seen this. I've never seen it in my lifetime. How do you know how to do that? Well, we did problems like that in my beginning algebra course. So if you're a little rusty on it, that's okay. If you're claiming you've never seen it, that's not okay. All right, and by the way, I forgot to put the units there. We need mi for miles, mi for miles, mi for miles, and that is our final answer. So don't claim that you've never seen it or else you didn't follow my directions. There are prerequisites for this course. You can't just take the course without satisfying the requirements. All right, so on to, that was just a specialty problem, so just be aware that sometimes you might have to cut that distance in half. So now we're going to do some challenge problems. I don't want to scare you. I mean, they're not really that difficult. They're just the typical types of problems that you'll get, variations of these problems that you may see, so I want you to be exposed to this. If the point 2, 3 is the midpoint between points A and B, and the coordinates of B are 1, 1, what are the coordinates of point A? So I know that seems kind of confusing, but all this is saying is if you have the coordinates 2, 3, which may be here, for example, and that's the midpoint, I'll call it M for the midpoint, and you have the coordinates B, which are 1, 1, which would be about here, that's point B. They want to know what are the coordinates of of point A. So point M is the midpoint of point A, so point A has got to be somewhere up here. So the difference for this problem is that instead of giving us these 2 points and asking for the midpoint, they're giving us the midpoint and one of the endpoints and asking for the other endpoint, you see. So this is kind of a challenge problem. Now, we know, let's look at our midpoint formula here. That's our midpoint formula, right? So we know that the x value, we're going to break this up into 2 equations. We know that the x value of the midpoint is equal to that expression. I guess I could just say x value of the midpoint. That's one equation. And the other equation is we know that this expression is the y value of the midpoint. So I just put little m's because that means y value and x value of the midpoint. But here's the thing. We know the x value of the midpoint. They gave us the midpoint up here. So we know that the x value is 2. We also know that one of the x values of the 2 endpoints is 1. So for x1, I can plug in 1. It doesn't really matter which is which because we didn't assign b as 0.1 or 0.2. It doesn't matter. So I can just make it I can just make x1 equal to 1 because the x value of that point is 1. And now we're just looking for the x value of 0.2. And so now it's just an algebra problem. So what we're going to do is we want to get rid of the fractions, so we're going to multiply both sides by 2. So I guess I can go ahead and do that. So I'm multiplying both sides by 2, and that gets rid of the fraction. And we have 4, so these 2's just cancel out. And 2 times 2 is 4. So now I just subtract 1 from both sides, and I get the x value of one of the endpoints is 3. Now I do the same thing with this equation. I know the y value is 3. You see this y value up here? I'm going to plug that in there because that's the y value of the midpoint. So that would be 3. And I know the y value of the point that we know, the endpoint that we know, that's going to be 1 also. So plug that in. It doesn't matter which one you plug it in for. Then we're going to multiply both sides by 2, and we get 6. I'm not going to show that every time because it's just going to be tedious. Subtract 1, and we get 5. So the y value of that endpoint is 5. So now we can write the final answer. So the point that we're looking for, point A, is 3, 5. So this is the exact same thing that we've been doing. The only difference is we're given different information, and we're asked to find one of the endpoints given the midpoint, and one of the endpoints we're asked to find the other endpoint. All right, now I want you to try number 29. We don't have time to do a lot of these problems, but I just want to get you a feel, get a feel for the types of variations of the problems out there. So try 29. I'm going to leave 28 in the window, and when you come back, we'll do it together. All right, we're back. So again, we know x1 plus x2 over 2 is equal to the x value of the midpoint. And we know y1 plus y2 over 2 is equal to the y value of the midpoint. I'm not going to write the midpoint formula because you can already see it over there. Now we know that the x value of the midpoint is 7. You see the 7 here? That's the midpoint. So we know 7 is the x value of the midpoint. And we know an x value of one of the endpoints is -3, so we can plug in -3. It doesn't matter if you plug it in for x1 or x2. Multiply both sides by 2, and you get, and it just gets rid of the fraction there. And it multiplies 7 by 2 to get 14. Add 3 to both sides, and we get x2 is equal to 17. Now we're going to plug in the y value of the midpoint. That is -2. And we're going to plug in the y value of the point that we have, one of the endpoints that we have, which is -4. Doesn't matter if you plug it in for y1 or y2, you get the same answer. Multiply both sides by 2, we get -4 is equal to -4 plus y2. Add 4 to both sides, and we get y2 is equal to 0. So the coordinates of point D are 17 and 0. We should probably label that point D. So if you got that answer, good job. Now a way to check your answer is use point C and point D, and then use the midpoint formula and see if you get the midpoint. So 17 plus -3 is 14 divided by 2 is 7. We got 7. And 0 plus -4 is -4. And -4 divided by 2 is -2. So we got -2 for the midpoint. So I calculated, let me get rid of these highlights. So again, I just said -3 plus 17 is 14 divided by 2 is 7. So the x value of the midpoint checks out. And -4 plus 0 is -4 divided by 2 is -2. And we have -2. So that checks out. All right, so that's just a variation of a type of problem that you'll see. And this is pretty much the same thing. But now we're just using coordinates. So it says, if the deli is halfway between the museum and the church, find the coordinates of the museum. So we have the church and the deli on the graph here. And the deli is halfway between the church and the museum. So that means the museum is going to be down here somewhere. But again, we're just going to use that formula. We're going to break it up into 2 parts. So we know that x1 plus x2 over 2 is equal to the x value of the midpoint. And we can go all the way down here just to save room, or just to make it easier. y2 plus y1 plus y2 is equal to the y value of the midpoint. And so I'm going to go ahead and write these coordinates. I'm going to label this M because this is the midpoint, and that is 2, 2, negative 5. And this coordinate is looks like it's 4, 5. So the deli is the midpoint, you see. So 2 is the x value of the midpoint. And we have another x value, which is 4, one of the endpoints. And we just solve that equation, multiply both sides by 2, and subtract 4 from both sides, and we get x is equal to 0. So that's the x value of the coordinate of the museum. So now we're going to plug in the y value of the midpoint, and the midpoint is the deli, so the y value is negative 5, and a y value of the other point there, the church, is 5. Again, it doesn't matter which one you plug it into, the y1 or y2, you get the same answer. Multiply both sides by 2, and you get negative 10 is equal to 5 plus y2. Subtract 5 from both sides, and you get negative 15. So now we can combine these two, and we see that the museum is at coordinate 0, negative 15. All right, which is somewhere down here, that's where it should be. So these are just word problems using the midpoint, and they're challenge problems because you're given the midpoint, and you're given one of the endpoints. You have to find the other endpoint. So I want you to try a problem like that. I'll go ahead and leave the museum problem in the window. Try 31, and when you come back, we'll do it together. All right, we're back. So let's write the coordinates. We have 1, 0, and 4, negative 1. Now, it's important that the school is halfway between the factory and the post office. So that means the school is the midpoint. So I'm going to go ahead and write M next to that coordinate. That shows us this is the midpoint. And the school, what are we looking for? The factory is going to be somewhere over here, right? Probably like right there. A lot of students would say, "Well, I can just eyeball it." Well, you know, don't take risks like that. There are ways you can do it without the formula, but let's just stick to the formula for now. So we know x1 plus x2 over 2 is equal to the x value of the midpoint. We know y1 plus y2 over 2 is the y value of the midpoint. We know the x value of the midpoint is 1 because that's the school, and we have an x value of another point. The post office x value is 4. Multiply both sides by 2, and you get 4 plus x2 is equal to 2. Subtract 4, and you get x2 is equal to negative 2. And plug in the y value of the midpoint, which is 0. That's the school, remember. And post office y value is negative 1. Multiply both sides by 2, and you get negative 1 plus y2. Add 1 to both sides. y2 is equal to 1. So we have negative 2 and 1. That is the coordinate of the factory. Let's see if that makes sense. 1, 2, 1. So it should be right there. Does that make sense? Yep, it looks like it makes sense. So that's a good way to check your answer. All right, so if you got those answers, good job. All right, we have 4 more problems here. We're going to do some more challenge problems. If the distance between negative 4, 1, and 2y is root 37, find the possible values of y. So now we're going to use the distance formula. All right, the challenge problems that we just did, they're all midpoint problems. Now we're going to do some challenge problems with the distance formula. So let's go ahead and write the points. So we have negative 4, 1, and we have 2y. Notice we're missing a y value. They just gave us a letter. Now we're going to assign letters so we know what to plug into the distance formula. And we're going to write the distance formula. And we're going to plug in what we know and solve for what we don't know. So do we know the distance? Yes, we do. They gave us the distance. It's root 37. Root 37. So you just plug in root 37 for D. And do we know x2? We have we have the two coordinates. You see, so we know x2 is 2 because we labeled there, and we're going to subtract x1, which is -4, and y2. Y2 is actually just y. Remember, that's the letter that we don't know, and we're going to subtract y1, which is 1. So the only difference is we're just plugging in the distance. And the previous problems, we were looking for the distance. Now we're not looking for the distance. We're given the distance, and we're looking for a value of one of the coordinates. So now we just have to solve this equation. And the first thing we're going to do is get rid of the square roots. When we have square roots on both sides of the equation, we just get rid of both square roots at the same time. We learned how to do this in my beginning algebra course. If you're rusty on it, that's okay. If you've never seen it, that's not okay. Square both sides. So I'm going to go ahead and rewrite and go and square both sides there. I don't really need to show this, but I just want you to be absolutely clear what's going on, so I'm not going to skip any steps here. So you're squaring both sides. Now squaring gets rid of square rooting. We showed in previous problems that if you square root, you can get rid of the square when you have c, right? Well, what if you start with a square root? You can use a square to get rid of the square root. It's just the opposite direction. But it gets you to the same expression there. So squaring just gets rid of that square root, and we're left with 37. And squaring gets rid of the square root on the right side, so we're just left with, it just gets rid of the root. I probably should have simplified these inner parts before I did that, but it doesn't really matter. So now 2 minus -4 is 2 plus 4. And you don't have to show all these steps. Like I said, I'm just going very slow here just to be absolutely sure you see what's going on, because these are challenge problems. And we have 37 is equal to 4 plus 2 is 6. And that would just be 6 squared is 36. All right, so at this point, we have an equation with squares. Now, a lot of students are going to say, this is not fair. I've never seen this. Yes, you have seen this. If you took my beginning algebra course, you've seen this before. We have an equation with squares. The first step is to isolate the square. Now, again, if you're rusty on this, that's okay. If you've never seen it, that's not okay. We're going to isolate this square, so we're going to subtract 36 from both sides. So that gives us 1 is equal to y minus 1 squared. Now we've isolated the square. So now we're going to get rid of the square. The second step is to square root both sides once you isolate the square. Remember, the opposite of squaring is square rooting. And remember, you have to put plus or minus. And what is the square root of 1? What number times itself is equal to 1? Well, obviously, that's just 1. And that gets rid of the 2 power on the right side. And, you know, I know what you're thinking. You're thinking, I've never done this. You have done this in my beginning algebra course. And if you want some practice with it, you can go back to my class on solving equations with square roots, or some variation of that title. That's my beginning algebra course. So now we're gonna pretend we're gonna break this into 2 equations. One equation we're going to pretend it's y minus 1 equals, or excuse me, positive 1 equals y minus 1. And the other equation we're going to pretend that it's negative 1 equals y minus 1, because again, it can be plus or minus. There's actually 2 answers. So then we add 1 to both sides and we get y is equal to 0. And we add 1 to both sides over here and we get y is equal to 2. So there's actually 2 solutions. And you might be thinking, well, wait a second, why is there 2 solutions? Well, if you graph this, we have negative 4, 1 here, and we have 2 something. So it can actually be here or here. It'll give you the same length, and that's why there's two possible answers. All right, so let's try one more of those problems together before you try one on your own. So we're going to write out those coordinates, and we can use the distance formula. That's what these problems are all about, the distance formula. And do we know the distance? Yes, we do know the distance. It is 2 root 17. That's the distance. x2 is going to be 2, and x1 is just x, and y2 is 3, and y1 is 1. And the first thing we need to do is square both sides to get rid of those square roots. So I'm squaring both sides. I want to move this over a little bit. So now this is another thing that students would have a lot of trouble with or anxiety about. 2 root 17 times 2 root 17. We learned how to do that in my beginning algebra course. That would just be 2 times 2 is 4, and root 17 times root 17 is 17. So that becomes 4 times 17. And it just gets rid of the square root on the right side of the equation. And 4 times 17 is 68. And now we're left with, well, 3 minus 1 is 2, 2 squared. Just keep going here. Again, you can skip steps here, but I'm trying to go real slow so you can see exactly what's happening. So now we have an equation with the squares. So we just isolate the square. We get 2 minus x squared by itself. Subtract 4. We get 64 is equal to 2 minus x to the second power. Now we need to get to the second step is to get rid of that power. So we square root both sides. And remember, whenever you square root, you have to put a plus or minus sign. What number times itself is equal to 64? Well, that's obviously 8. And the square root gets rid of the power there on the right side of the equation. And now we're going to break it up into two equations, because it can be positive 8 or negative 8. So if it's positive 8, we have 8 equals 2 minus x. And if it's negative 8, we have negative 8 equals 2 minus x. And then we just solve. So solving on this side of the equation, we are going to subtract 2 from both sides, and we get negative 10 is equal to negative x. Divide both sides by negative 1, and we get x is equal to 10. And over here, if we subtract 2 from both sides, we get 6 is equal to negative x. Divide both sides by negative 1, and we get x is equal to negative 6. Students have a lot of trouble when you have a negative in front of a letter like that, but that's just beginning algebra stuff. So those are our two answers, and I forgot to rectangle those on the previous problem. Sorry about that. Make sure to rectangle your answers. So in that particular problem, there's two possible solutions. So now I want you to try number 34, and when you come back, we'll do it together. All right, we're back. Let's go ahead and write these points out and assign letters to them. And here's our letter assignments. And we're just going to use the distance formula. Again, it doesn't matter which one is 0.1 or 0.2. And do we know the distance? Yes, we're given the distance is root 65. And we plug in the other numbers. x2 is equal to x. x1 is equal to negative 5. A lot of parentheses happening there. y2 is equal to negative 1 minus y1 is 3. And we're going to square both sides. I'm just going to copy that because I don't feel like writing it out again. So we're going to go ahead and square both sides to get rid of the square roots. That's the first step. And we end up with 65 is equal to x minus negative 5 squared plus negative 1 minus 3 squared. Again, I'm not skipping forward here at all. I'm taking my time, I don't want you to get confused. Double negative becomes a positive. Negative 1 minus 3 is negative 4. We can go ahead and square negative 4, and we get 16. Subtract 16 from both sides, and you get 49. So we isolated the square, and now we want to square root both sides to get rid of that square, because we can't find x unless we get rid of that square. And then whenever you square root, remember you have to put a plus or minus sign. So that's plus or minus 7. Square root of 49 is 7. What number times itself is equal to 49? Well, that's 7. And now we're going to break it up into two parts. We're going to pretend that it's negative 7. And we're going to pretend that it's positive 7, because it can be either. Subtract 5 from both sides, and we get x is equal to negative 12. That's one answer. And subtract 5 from both sides, and x can be 2. That's another answer. So if you got those answers, good job. All right, so we're going to try one more of these problems, then we'll be done for the day. At least I'll be done. You'll have to do your homework. So try number 35, and when you come back, we'll do it together. All right, we're back. So let's write these coordinates and the distance formula. And do we know the distance? Yes, we do. It's 5 root 5. Plug in all the other numbers. 0 minus y squared plus 2 minus, whoops, that was wrong. Sorry about that. 0 minus 5 squared plus 2 minus y squared. We're going to square both sides, and 5 root 5 times 5 root 5 is 25 times 5. You just square the 5 and you square the root 5. Whenever you square a root, you just get rid of the root. And again, that's the part that a lot of students are going to have trouble with. They're going to complain a lot about that. But again, if you've taken my beginning algebra course, you should have that down. If you're rusty on it, that's okay. There's no problem with that. But again, if you say, I know I'm sounding like a broken record, but if you say you've never seen that, that's a big problem. All right, so 5 times 25, that would be 125. And 0 minus 5 is negative 5. Make sure you keep those parentheses. Negative 5 squared is 25. So now we have an equation with a square. So we isolate the square. We get this square by itself. Subtract 25 from both sides, and we have 100 equals 2 minus y squared. And now we want to square root both sides. Whenever you do that, put a plus or minus on the side other than the variable, the side without the variable. And what number times itself is 100? Well, that would be 10. And it just gets rid of the square on the right side of the equation. Now we're going to subtract. We're going to break it up into two parts because it can be plus or minus 10. So we can assume it's negative 10 equals 2 minus y, or it can be positive 10 equals 2 minus y. So subtract 2 from both sides, we get negative 12 equals negative y. And divide both sides by negative 1, and we get y is equal to 12. That's one of our solutions. Subtract 2 from both sides, we get 8 is equal to negative y. Divide both sides by negative 1, and y is equal to negative 8. That's the other solution. So if you got that answer, good job. So that is the class today. Now, if you want to take screenshots of the work we did today to help you with your homework and study for tests, you can go ahead and do that now. All right, now let's get some screenshots of the homework. So go ahead and get a screenshot there. Get a screenshot of that page. And a screenshot of this page. And that is your homework. So be sure to do that homework completely and correctly. And the reason I give you the answers is because you have to check your answer. If you don't do it correctly, you're just wasting your time. Do it completely, correctly, and neatly. And be sure that you know where your homework is. You need to put it in your binder in the proper order. If it's not in the proper order, you're not doing it correctly. And I'll look forward to seeing you in the next class. But remember, again, if you don't do the homework, this entire course is a complete waste of your time. I'll guarantee you that you'll learn absolutely nothing unless you do that homework, all of it. So again, that was the class today, and I'll look forward to seeing you in the next class.